Runout or runout is an inaccuracy of rotating mechanical systems, specifically that the tool or shaft does not rotate exactly in line with the main axis. For example, when drilling, runout will result in a larger hole than the drill's nominal diameter due to the drill being rotated eccentrically. In the case of bearings, runout will cause vibration of the machine and increased loads on the bearings. Runout is dynamic and cannot be compensated. If a rotating component, such as a drill chuck, does not hold the drill centrally, then as it rotates the rotating drill will turn about a secondary axis. Runout has two main forms. Radial runout is caused by the tool or component being rotated off-center, that is the tool or component axis does not correspond with the main axis. Radial runout will measure the same all along the main axis. Axial runout is caused by the tool or component being at an angle to the axis. Axial runout causes the tip of the tool rotate off-center relative to the base. Axial runout will vary according to how far from the base it is measured. In addition, irregular runout is the result of worn or rough bearings which can manifest itself as either axial or radial runout. Runout will be present in any rotating system and, depending on the system, the different forms may either combine increasing total runout, or cancel reducing total runout. At any point along a tool or shaft it is not possible to determine whether runout is axial or radial. Only by measuring along the axis can they be differentiated. Absolute alignment is not possible. A degree of error will always be present. Radial runout. Radial runout is the result of a rotating component running off-center, such as a ball bearing with an offset center. This means that the rotating tool or shaft, instead of being centrally aligned, will rotate about a secondary axis. In general, cutting tools are more tolerant of radial runout since the edges are parallel to the line of cutting, tending to keep the tool tip aligned. However, a rotating shaft may be less tolerant of radial runout since the center of gravity is displaced by the amount of runout. Axial runout. Axial runout is the result of a rotating component not being parallel with the axis, such as a drill chuck not holding the drill exactly in line with the axis. In general, cutting tools are less tolerant of axial runout since the tool tip tends to dig in and increase runout. However, a shaft may be more tolerant of axial runout since the center of gravity is displaced less. Measurement. Typically runout is measured using a dial indicator pressed against the rotating component while it is turned. Total indicated runout is a technician's term for the measured runout of any rotating system, including all forms of runout, at the measured point. See also, geometric dimensioning and tolerancing, references.